So this is going to be a quick run through of the code base that we've written. I'll describe how things work and just generally show you around. So the project really starts here in the config.js file. And here we're storing all of our secrets for the newsapi.org and the Amazon Web Services API keys that we need to store. And this is in the gitignore, and we have like an example file which people can use to make sure that we're not exposing our keys on the public web. We're also storing here the time between each headline. So this is the amount of silence between each headline that's written, and then our search terms along with how many search terms should be gathered for each term. So this is the config. There's also this utilities file. We've just abstracted away some of these slightly more utility style functions into this module, which can be imported into our separate scripts. So we've adopted a kind of microservices architecture for this. It seemed more appropriate, and we explain why in our report. But starting over here on the first script, reasonably short, it essentially just calls off to News API with our query and with our API. It gets the results. It only stores the first X many, where X is the number, is the count from config, and it puts them each into their own JSON file. So to show you how this works, if we just run node one fetch articles, it will go away and do that, and it will store 3 JSON files here, each one with a bunch of headlines. The reason this is separate from everything else is it gives us a chance to manually vet the news stories that are coming back. Sometimes things weren't making sense. Our text-to-speech service, which I'll talk you through in a moment, would like read out hashtags and different bits of punctuation, and it just gives us a chance to make sure that things that are being said by the Furby actually make sense. The second script here is create MP3, and we're using Amazon Poly for this. We tried a whole bunch of different services, and we talk a bit about that in our report as well, but we landed on Amazon Poly. So what this does is it reads each one of these JSON files in the order that they're dictated in the config file, and it will put together this kind of XML file, or using XML verbs here, this thing called SSML, which Amazon Poly accepts. So we're telling it to be loud, we're telling it to have some effects on, and to read out each of the titles of the articles which are stored in this JSON file. It sends it off to Amazon Poly, and what it does at the end is it creates a set of MP3 files for us. And again, you'll notice that like all of our config, our things that we don't want to make public, are stored away in the config, which is in the gitignore. So to show you how that works, we're just going to run node to create MP3s, and that's it. That's a bunch of MP3s there. Talk you through how this works. The first number here tells you which search term it is, then the actual term itself, then which index it is, which means they all come in the right order, and then the final number is the number of seconds which that file lasts, because it felt easier than having to work it out in the next part. The third file is the orchestrator, and this is the file which will actually run on the Furby itself. So this one actually won't work on my computer, but it works when it's on the Pi, and we'll show you a video of that. A few interesting things before I get into it. We're running some Python scripts inside of this Node app, which is what runs on the Furby. We're also using child processes in Node, which were like reasonably difficult to figure out how to get to work. But you can essentially, trigger child services on your machine and then kill them and get like console output from them, which is really awesome, and that's built into Node. First thing we're doing is we are just storing all of the files in here, where we are figuring out their duration by just getting this number here and storing it along with the whole file name. Next, we're using this loop here, which will run through all of these MP3s with a timeout. So there is suitable pause in between, and getting this to work was also quite a challenge. But essentially what it does is it creates this, which is a child process using the Python shell node module. It will run the Python script, which I'll show you in a moment on the Pi, which physically moves all the motors, and it just does some like error handling and logging for us here. And then here we're running a child process, and we are using MPG321, which is a little command line application which allows us to play MP3s straight into the speakers. Then we sleep for the amount of time of the track plus the gap in between, which we store here. So there will be 5 seconds in between. And then it will go again. And when it reaches the end, it will loop all the way back to the top, which is here, and it will just keep going infinitely. So that's how that file works. The final one here, actually just says, hey, send power to these pins and turn it off. And this is what actually moves the Furby here. So this isn't a Node app. This gets run by the orchestrator. So essentially the way this works is we plug into the Furby and SSH in over USB, and then we run orchestrator. And as long as the Furby remains powered, we can then unplug the machine and leave the Furby to just go in an infinite loop. Everything's stored offline, and the idea is that we generate these news articles each morning before the show, we vet them, we generate the MP3s, and then we just leave the orchestrator to run. So hopefully that helps explain our code and give you a little bit of an overview of the technical aspects of this project, and hopefully you enjoy it. Thank you.